Welcome to The Explainer. Today, we're tackling a really fundamental concept in programming, arrays. But we're going to look at how Python handles them, which is, well, it's in its own unique and pretty powerful way.
So, let's kick things off with a common problem. Imagine you're coding a game, and you need to keep track of, say, 50 different scores. How do you actually store all that data?
I mean, you could create a new variable for every single score, right? Score 1, score 2, score 3, all the way up to 50. But oh my gosh, what a nightmare that would be to manage. It's messy, it's clumsy. There has to be a better way.
Okay, let's dive into this. This is where Python's solution comes into play. It's really elegant, but honestly, it's also a common point of confusion for beginners because Python's just a little different.
So here it is, the most crucial point you need to remember. Python doesn't really have a traditional array like other languages. Instead, it uses its super flexible and powerful built-in list. So when you hear someone say array in the context of Python, just think list. It's the tool for the job.
Let's start by building our first and simplest data organizer. We're going to look at a single list of items, what we call a one-dimensional or 1D list.
You know, it's a really simple three-step process. First, you have to create the container. Then, you put your stuff into it. And finally, you take that stuff out to look at it when you need it. Easy.
So step 1, we tell Python we need a list, and we'll call it scores. Now this square bracket 0 times 5 part, that's just a slick Python shortcut. It says, hey, give me a list with 5 spots, and fill them all with 0 for now. Super clean way to get started.
All right, step 2, putting our scores in. We just use a loop that runs 5 times. And inside scores of I is where the magic is. That I is the index. It's the position in the list, starting from 0. So as the loop runs, we put each new score into its own slot, from index 0 all the way to 4.
Then to get the data back out, well, we just loop through the list again. See how similar it looks? For each position I, we use scores of I to grab the value we stored there and print it out. Simple, organized, and really efficient.
Now, a single row of data is great, but what happens when your data is more complex, like a grid? This is where we take the next logical step, from a 1D list to a 2D list. And a 2D list is literally just a list that holds other lists inside of it.
Let's move on and see how this builds, because with this concept, we can now handle data that looks like a table or a game board or a spreadsheet. Anything with rows and columns, really.
Okay, this code might look a little intense, but it's simpler than you think. You just have to read it from the inside out. The inner bit creates one row with 4 columns. The outer part tells Python to do that 3 times. And just like that, you have a list containing 3 rows, a 3x4 grid.
To fill it, we use nested loops. It's a loop inside of another loop. The outer one handles the rows, and the inner one handles the columns. This lets us use grid row call to target any specific cell by giving it coordinates, just like in Battleship.
And this is just a beautiful way to display it. We loop through each row in our grid. For each row, we loop through all the values inside it, printing them side by side. Then, once a row is done, the empty print at the end just bumps us down to the next line. Presto, your grid is printed out perfectly.
So we've gone over the how to make and use these lists. But maybe the most important question is why. Why should you even use these things in your code?
This is the payoff. This is your new toolkit. Instead of 100 loose variables, you have one neat container. You can organize complex data, like a game inventory, in a way that just makes sense. And that makes your code so much cleaner and easier to manage with loops. Seriously, this is absolutely foundational for almost any program you'll ever write.
So the real takeaway here isn't just about code syntax. It's a whole new way to think about data. You now have the fundamental tool to manage collections of information. So the question I'll leave you with is this. Now that you can organize data, what bigger, more interesting problems are you going to solve?